was flipping through and deleted some stuff at the last minute here. So, at the end of class, we had finally, after a long, hard go all semester of crawling through these classes, had gotten to start talking about mammals. And so we started to introduce the characteristics, right? And at this point, really all the characteristics are unique because there's no more classes after us to share our characteristics. So we had 8 different, characteristics that held mammals together as a group or a class. And then we started looking at a select few of these that were a little more interesting or easy to look at in close detail. And specifically in this case, we really have been focusing on the function of the mammary system, right? And its relationship with the integumentary system, right? So last time we really focused on lactation, right? We know this is something that is really special to mammals and why it's important both for babies and for mom, okay? Then we looked at the different levels of the integumentary system, right? In particular, the epidermis and the dermis, just at a glance to see where they are and what the major features that we would find in each. And then we started talking about some of the things that come out of the epidermis and the dermis. So this leads us to one of the next major unique features that are especially mammals, right? Which come from the epidermis, right? And then as we know, since that dermis, right, so the epidermal layer being made out of keratin, right, is where the development, right, because hair also has a lot of keratin in it. So this is where hair is made, right? But they need to ultimately be embedded into something much deeper. Remember, the epidermal layer is very thin. So we're drawing, right? So here's our epidermis, right? That's very, very thin. Okay, so that wouldn't be deep enough to hold anything. So even though that's where our keratin is found, and this is where the development of things can be, okay? Our dermal layer, remember, is our thick layer, okay? So not only is this thick enough to actually be able to hold most, right? If we're stuck, we don't know. Our best guess is going to usually be the dermis. Okay, this is where all the interesting stuff usually is happening. And this is going to be the case here as well. Okay, so the actual embedded hair follicle is going to be found in the dermis. So this is why we have both epidermis and dermis listed. So it's made in the epidermis, right? But housed or holded or embedded. That is not even remotely how you spell embedded, but that's cool. We're going to write it. We're going to write it out, okay? In the dermis. Okay, now, hair being important and unique to mammals, okay, serves a whole bunch of different functions. Okay? From being pretty, allowing to sexual selection, species selection, a lot of these things that we talked about in our reproductive isolation unit, right? How do I recognize another organism is similar to me, right? I know a human is similar to me because they have similar type hair patterns versus a dog, right, which is completely covered in hair. So other ways you can tell, but this is helpful. Right, now, hair also does, importantly, right, other functions. Now, mainly we know that being hairy helps with things like insulation. Okay, and largely, okay, we can think of our hair when we think of that, particularly when it comes in mass, or what we call pelage, which is the technical term for fur. Okay, and really all this means is hair is covering a large portion of the body. Okay, so when we're talking, and I'll come back to talk about vibrissae in a second. When we're talking about pelage itself, right, fur, and we can break that down into two pieces as well. Okay, the underhair, so if we kind of think about like taking a cat, for example, right, we kind of pet them backwards for a second. They love when you do that, right? Okay, when you pet the cat backwards, you get the really like lighter colored, floofy stuff underneath. Okay, so quite literally being underneath is that underhair. Okay, it's a little bit floofier, right? A little bit frizzier. Okay, not quite as sleek. Okay, so we kind of call that down, right? Like you would imagine down feathers also being a little floofier. Okay, so this is the part that's giving any of our mammals more insulation. Okay, it's got that fluffiness, it's that softness, it's closer to the body. Okay, so it's trapping body heat. And this is also most of the stuff you deal with when you're dealing with shedding. Okay, collectively or alternatively then, the other option, the stuff very much right on top, so we're going to pet all the fur back down flat. Okay, the stuff that tends to be sleeker, okay, shinier, a little bit tougher, particularly if we kind of think about dogs or short-haired cats. Okay, this is almost, it's not soft, it's a little pokier or stabbier compared to the floofy stuff. These are very technical terms, right? Okay, are called guard hairs. Okay, because their job is to literally guard the body or guard those underhairs as well. Okay, so the shininess usually has some kind of waxy or keratin coating on it, much thicker than our underhairs have. And it protects from a series of things. So this isn't great for mechanical protection. Remember, mechanical is like physical. But it is really good for everything else. They're tightly packed. It helps to keep bugs and stuff out to some degree. It also will help protect the animal from water, a little bit of waterproofing. There's UV protection in there, depending on its density, right? All of these other pieces. So most animals that have pelage have these two layers. Okay, we don't, right? Because our hair only covers one part of our body. Now we may have different density in our hair, it's just not that exciting. So when we're talking about shedding then, okay, no matter what kind of hairs we're shedding, whether it's our hairs or that pelage, this has two goals then. The first of which, kind of like when we talk about shark teeth, okay, hairs wear down, okay? Particularly when we're talking about these guard hairs, just like when we're talking about shark teeth, the stuff that's on the outside needs to be in tip-top shape all the time, okay? So if you're a guard hair, you're kind of the outer coat, and you start to get short or broken or bent, okay, then you're going to be doing a really crappy job. You're not all going to be lining up. You're going to be leaving gaps in that coat and letting water in or letting sunlight through or bugs through. So when hair gets like that, time to go. Okay, so that's when we shed guard hairs. They don't tend to go in mass, right, unless the animal has done some sort of activity that's damaged a lot of hairs at once. Okay, we also shed our underhairs. This is something we're probably more familiar with. Okay, this is more like a seasonal change thing. Okay, we want the underhairs, the floofy things, to go when it gets quite warm. And these do tend to come out in mass, right? Particularly a very fluffy animal, they may actually pull out patches, right? I'm hot, coat's got to come off. Okay. Now, the other type of hair I have up here, keep in mind, remember, there's lots of ways that we can adapt hairs to work for our body, right? Quills are hair, baleen, right? They're kind of like the soft teeth in whales, are hair. Okay, but vibrissae are the other type of hair I want to talk about. Okay, this is fundamentally just whiskers. Fancy word for whiskers. Okay, the only reason I brought them up as well as opposed to some of these others is because they're also super common. Okay, quills and all of these other adaptations are really unique to like one or two species, whereas pelage and vibrissae, whiskers, right, are more common across several families. All right, so vibrissae, right, are much stiffer hairs, right, and they're bundled with a lot of nerves in the face. Right, so these do several things, but largely, right, are giving our organisms, right, physical input about their space. So one is kind of the ability to see in the dark a little bit, right? I can feel the space around me and build a three-dimensional image, okay? In addition, right, most mammals use this to understand whether they can fit through spaces, right? So my whiskers are usually as wide as the fattest part of my body, which with most mammals is either the face or the hips, right? So with a rat, like the biggest part is their head. With cats, it's either the head or the hips. So if my whiskers can get through a space without having to bend, then I can fit through the space without getting stuck, right? So it's a low-risk way of testing an area. All right, so we shoved hair in our dermis. Very exciting. Any questions about hair? Now, hair is going to act this way fundamentally no matter what we do with it. Right, so when we modify hair, really all we're doing is modifying the part that extends out, right, to pointy or softer or shorter or whatever it is we're doing. Okay, so the last thing we want to talk about, we're talking about the integumentary system, our skin, okay, or how do all of these different glands, right, mammary being one of them, sweat was another, right, these were two of our unique structures, okay, that only mammals have, work together or work at all, right, within the dermis. Okay, so as again we're thinking here, everything is still, let's see if I can try it again. Just gonna embedded in the dermis. All right, this is our excitement zone. Okay, and we're only listing the epidermis at this point because we have to pass through. Right, everything has to come out through that top layer. So we're going to be secreted out through. Okay, just like the hair. Okay, it's got to come out through that top layer. But just like the hair, right, that top layer is too thin to actually hold any of this stuff on its own. Okay, so let's talk about sweat glands first. Okay, so we can see, and here's my epidermis. And my dermis here. Okay, so again, housed in that thick layer, okay, which is going to be our default. So we've got two different types of sweat glands. Okay, and the difference here is really location. Okay, because sweat is sweat, really. It's just creating a hormone-based water or fluid that's being secreted out of the body with the goal of evaporating, right? Because when we evaporate something, it cools for us. So both of these are secreting the same kind of fluid. Okay, so all that's different between them is where are they doing it? Okay, so eccrine and apocrine. Okay, our eccrine, okay, are more common. Okay, they're spread out all over. Right, so when you get that weird sweat behind the knees kind of feeling, okay, sweat down the middle of your back, okay, All of our favorite kind of uncomfortable sweats. Okay, your butt sticks to the chair. Okay, these are all eccrine sweat glands. Okay, so we can see this one here. Okay, so they're found all over by the body, okay, and they're not connected with anything. They're the lone wolf sweat glands. Okay, so they're found by themselves in the dermis. Okay, and they journey by themselves through the dermis, through the epidermis. Okay, so they have their own individual pores or their own individual exits through the skin surface. Now, comparatively, our apocrine glands also going to make you sweat, but are located in more specific areas. Okay, more specifically, these are going to be associated with those hair follicles we just talked about. So these are going to be the ones specifically located in like our armpits and our groins. Yay! And so we can see this over here. Okay, where this particular, so very similar even in structure, right? But this particular sweat gland, right, is found right up against, right, or associated with that hair follicle. Right? And as we look, okay, instead of going out its own door, right, the sweat gland is actually dumping into that hair follicle pathway. So the sweat will actually come out the same exit that the hair does. So we're sharing a highway. Okay, so again, same sweat. Okay, we're just sharing a space.
So this might be like too extra for what we're going over. How does like heat trigger sweat?
All right, so her question is, how does heat trigger sweat? So the key here when we're talking about this is homeostasis, right? So your body, or in this case, most importantly, your internal organs, right, tissues, only function within a certain range. So once those organs or tissues start to get above that range, okay, so for you, above like 100, they start to get uncomfortable. Okay, your metabolism needs to start cool that down, right? So your tissues recognize temperatures, cells recognize temperatures very easily, right? And a lot of that has to do with proteins, right? Proteins function within a very specific temperature range. When they get too warm, they start to break down or denature. They don't function well, right? So cells are very sensitive to that, and they will actively go through metabolic systems to cool themselves down, which in this case, since your body works in cahoots, right, it'll trigger mechanisms for your body to cool itself down. Now, your proteins in your body are not going to denature at like 99 degrees, so don't get me wrong. We're using very extreme examples here to put all of our pieces together. That is, however, why fevers of like over 104 are very dangerous, though. That is where your cellular proteins start to denature, and that's why you get very sick, and it's very dangerous to maintain that temperature. It's lower for babies. I'm not sure what it is, but that's why you have to be very careful with baby fevers. Great question, and good tie-in, all the way back to day one. Okay, so any questions about our two sweat glands? Okay, so remember sweat glands, right? So both of these being sweat glands, right, would be unique to mammals. Okay, humans also do have sebaceous glands. This is not unique. Mammals have sebaceous glands, right? Oil glands, okay? Lots of animals do have versions of oil glands, right? The preening gland in aves is a version of an oil gland, okay? So the key here is we have one of these. I'm bringing this up because our mammary gland here in a second is actually going to be a sister of this. Okay, but not surprisingly, we also have sebaceous glands. But we know that we get oily as well. Okay, our skin is oily. Okay, this is not necessarily a bad thing, right? And our hair also gets, that's hard to say. Ooh, our hair also gets oily. Say that 5 times fast. Okay? Now, most of the time, this is really helpful, right? Not only is it adding a little bit of waterproofing, okay, as well as a little bit of UV protection, but this is also going to prevent desiccation a little bit, right? We don't want as much of that air, water, and salt exchange to be happening through our skin. And so having a little bit of oil over the top, right, helps prevent that. Right? Now, too much of anything, of course, is a bad thing, but the small amounts that are normally released are good. Okay, so these are called sebaceous glands. Now, again, these aren't necessarily special or exciting in and on their own, right? Mammals have them, but like so does everything else. So why we care about sebaceous glands is because of the mammary gland. Right, so mammary glands, of course, are unique to mammals. Right, this is where our namesake comes from. So we've already talked about this a teeny bit when we started talking about lactation and why this is important. Right, so the mammary gland is a modified version of the sebaceous gland specifically, right? Milk is an oil-based substance. That's where it kind of gets its thickness and its fattiness, right? We talked about how milk was a really fat-based substance, which was important, okay? So the other thing I want to point out is that both sexes, right, both males and females, have mammary glands in all mammals, with one exception being koalas. Male koalas neither have mammary glands nor nipples because they're weird. Right, which we can wholeheartedly say since all other male mammals have their stuff together here. Right, so really only the difference is that in female mammals, when we go through puberty, our hormones trigger something to happen with the mammary gland, and in males, right, they just sit there. Okay, so those are all of the glands. Okay, so remember 3 of these are unique, right? Our eccrine, our apocrine, and our mammary. Right, the sebaceous, right, or oil glands in general are not unique to mammals, right? We just want to talk about them because of their relationship to the mammary gland. Okay, before we pop on to talk about the last layer of the integument, do we have any questions about our glands or the epidermis and the dermis? Pop out because my sound has been kind of funny. All right. So we've talked about the epidermis, right? That's that very top thin layer filled with keratin, goal is protection. We talked about the dermis, that's the very thick middle layer. Okay, and its goal is basically to house all of our super important stuff. Okay, our glands, our hair, okay, all of that, everything, right? This also is where most of our structure comes from. Okay. Lastly, okay, we have our hypodermis. Okay, this is also a fairly thin layer. Nope. Last day, had to happen. Sorry about that. So our hypodermis, right, this is the deepest layer. And again, we can see this layer is relatively thin, right? Certainly compared to the dermis, right, that thick central layer. Okay, this layer, okay, also is not going to have most of our exciting stuff, right? This is far too long of a journey for our hair or our glands to make if they were embedded this deep. So really the key here, or our nerves, remember our nerves are also found in the dermis. This is too deep for that. So the key here is, right, we have blood vessels and some tissues that run down through here, but they don't start here. Okay, so this is basically like a highway, kind of the way I like to think of it. Okay, and it makes such a good highway because this area is mostly fat. Okay, this is what our second bullet's talking about. Adipose tissue is fat tissue. Okay, which is why it's kind of shown as this like bubbly, chunky stuff. Okay, it's softer, it's floofier, it's part of what's holding your skin down, right? We know from doing our dissections, right, that fat is that nice like floofy tissue that holds everything down to the muscle. Okay, so that's where we're at with this. And it makes a nice, easy roadway for anything to pass through quite easily. Okay. If you have someone that's had third-degree burns, we say third degree because it's gone to the third layer of our integument, right? So this is the level that's been burned, and the reason it's problematic is because we've burned through all the layers that have the nerves in them, right? Okay, so this is why people who have had third-degree burns often lose sensation in those parts of their body, right? Because we've burned through all of the nerves, and nerves don't grow back very well. Right? Blood vessels and stuff can, or we can transplant blood vessels. Nerves are not as friendly with that. Okay. So hypodermis is important because it's acting as the highway, but it in and of itself does not really do anything besides store and hold things. Or hold things down. Also important. Okay. Any questions about our integument system? We covered a lot with it. This is one of the big sections we're going to do on mammals, right? There's a lot of big, really unique features about mammals here. Okay, so forgive this, but I actually cut both the internal anatomy and the sensory, which is largely talking about stuff we've talked about before. There was some turbinate stuff and some brain stuff here. Not that it's not interesting, but it's not as interesting as the stuff I kind of hope to get to. So my goal here is actually to pop down a few slides and to hit reproduction. So if you're following along with my slides, please forgive, right? My goal is not to be frustrating and just in the effort of our very little time together. So we're going to hit here if you're keeping up on those. I'm going to give you a hot second if you're following along. Which will leave us just reproduction and dentition if we happen to have time. Okay. If nothing else, then we'll finish where we once started on a Monday together many moons ago. Almost doesn't seem real. So way back at the beginning, right, we once started talking about mammals in our very first lab together. And when we were doing that, remember our goal was once to understand what even is a mammal. And one of the big tricks or frustrations with that is it turns out mammals are actually super weird and not at all this well fit together group that we kind of thought that they were. And reproduction is is one of the things that keep them as this kind of broken group. Okay? So, despite the fact we aren't doing a ton of taxonomy, there's a little bit of taxonomic review, right? Just the 3 that are worth looking at. Okay? So, the first of which, of course, is our Prototheria. In lab, we also call these Monotremes. I'm going to use Prototheria in here because it'll help us talk about the other groups with equivalent terms, right? We talked about them in lab as monotremes, right? Mono being one, so they had one hole, referring to their cloaca. Okay, Prototheria here, right, is going to refer to theria, is the suffix for mammal, right? So proto here, meaning early, kind of like prototype. Right, so these guys, remember, we spent a lot of time on them. I don't want to spend a lot of time on them again, okay? But they had a bunch of stuff that made things sort of complicated. So we know all of our mammals, remember, everything from reptiles on have internal fertilization. None of those rules are going to change here. Okay? Okay, and they did it. They have cloacals, so they're just going to use cloacal swelling, which is a lot of how our birds did it too. Got it. Good. Don't I learn any extra stuff. Okay, but they do some weird stuff, right? This group, remember what set them apart is they laid eggs. Yeah, baby eggs. Okay, there's our baby platypus. Okay. Cute, teeny, about the size of your thumb, top half of your thumb from your knuckle up. Teeny is all get out. Grossly inappropriate. All right. And remember, the other thing that was really weird about these guys is when we finally figured out, well, they actually do secrete milk via a mammary gland. We were thrown off for a while because out of all of the other mammals, they don't have nipples to do it. So they don't do suckling. And it's weird. Okay. So remember, this group's super small. Right? This is just platypus and echidna. Weird group. Okay, so those are our Prototheria. We're probably, at this point, pretty familiar with them. So then we have our Metatheria. Okay, so we still have that mammal suffix. Okay, meta is a weird prefix. It's like middle or almost. Okay, so these are things like our kangaroos, our wallabies, our koalas, okay? The vast majority of these, of course, living in like Australia and New Zealand, but like the possum, right? Our possum belongs here. And so anything with a pouch belongs here. Okay, now these guys, of all of them, probably have the weirdest system that they're using. Okay, now, still internal fertilization, right, still has to be. Okay, but the system they have, super weird. Okay, so up here, right, we have the lady's internal anatomy. Okay. So ultimately, okay, the key here is we have like 3 vaginal tracts and 2 uteri. Uteruses, I was going to make it uteri. Never has changed. Grad school didn't fix me on that one. They're not just like our snakes who have the 2 hemipenes, right? Our snakes are not using everything at once. That would be insane, okay? Our lady kangaroos and plus also not using all of these at once. That would be insane, okay? The idea here is basically as we have our joeys, and this is young metatherids are called, right, as they're coming out, all right, being birthed from a uterus, will come down the middle track. Okay, so babies have a special track. Sperm that's going up, right, looking for an egg to fertilize, I'm going to use that for blue, is going to go up a side track, right, heading towards. Because remember, fertilization happens in the oviduct, right? Okay, and that process, that splitting process, is aided with the two-pronged penis, which again, right, both sides, just like the hemipene, are not used simultaneously, right? We would use either one side or the other, right? But by having those two sides, it's like aiming. Okay, so here's what ends up happening. So remember that our metatherids, and our pouched animals, are having live birth. Okay. So these babies are born really fast. Okay, and this is the point of the pouch. So what we would almost consider like a neonate, just the term I've chose to use here, right? Something that is born too soon from like a human standpoint. Okay, so they're born like an embryo, a few days old, teeny, hairless, and small. Lucky kangaroo moms barely even feel it happens. All right, hardship on the baby joeys right after birth. Right, they have to crawl from the vaginal canal up mom into the pouch in order to survive. And this is the big goal. Now, once baby gets into the pouch, super safety, right? Inside the pouch, and why this is so important, it's warm, safe, and this is where all of the milk is, right? So this is where baby can stay and suckle. That's definitely how you spell milk. Until they've grown, okay? Which is usually quite an extensive period of time, right? This is the month to sometimes year period, right, that we would consider gestation to last for. And this is normally what we picture, like this almost full-grown kangaroo, like crawling in and out of mom's pouch, right? Those are the kangaroos that are just about ready to leave, not the ones that have just been born.
If they like are struggling to get to the pouch, will mom help?
So they can, usually by licking, but most of the time it's on baby to do the crawling. All right, so eutheria, this is where we'll stop. So here we have that theria ending. U, of course, means true. Doesn't actually mean we're true in any way. We have mammal bias when we name stuff. Okay? So this one feels really intuitive to us. We, of course, have internal fertilization. Aside from humans, most eutherids have what's called a baculum, which is literally a penis bone. Okay, which, as you might imagine, sort of makes the whole internal fertilization thing like a lot easier and more effective. A little more dangerous and can also literally be broken, but much more effective. Okay, and of course with us, unlike these other ones where we're getting like teeny embryos that are coming out after birth, the real big difference here is thanks to that placenta, right, which is allowing for feeding from mom, okay, baby can stay inside for months, right, because we can have continual and renewed nutrition. Okay, so we're still getting live birth, but baby is big. when it's born instead of very little and vulnerable. Swear I set that up like 8 times. Go! Stupid Socrative. All right, my dears. Guess we're ending on penis bone. Gotta commit. All right. When you're all done, there's so few of us here that you all can go. Please remain fabulous. You've all been so wonderful this year. I very much enjoyed it. I know it's been tough. Hopefully next year we'll have a little more flexibility. All right, please stay safe and continue to be fabulous. Mm.